This is Professor Pelton. This is Trigonometry, Chapter 2, Section 3, Trigonometric Inverses, or Inverses Trigonometric Functions. This is Part 2 of 2. So now we're going to get into the values of the inversed functions that are not the ones that are on the unit circle. At least not the nice ones anyways. Of course, all angles are on the unit circle. But these ones are not specifically the special right triangle ones, so they won't work out to a nice answer. So again, what this is actually asking is, what is an angle that gives me this? However, when you use your calculator to get the non-specific special right triangle answers, those answers are going to be approximate. And you can get two possible answers. You can get a radian answer, or you can get a degree answer, depending on how you're using your calculator. You will need either or, depending on the scenario in later chapters. You might need radians for the formulas, or you might need degrees to fill in diagrams. So let's practice using our calculator here. So we're going to do sine inverse of 1/4. Okay, so I do sine inverse of 1/4. I get this answer here, but this answer is in radians, so that is a radian answer. So I have to change my settings of my calculator. Every calculator is different. You need to figure out for yourself on your calculator how to do it. It's usually under mode or angle or something like that. Okay, so again, I'll type in the same thing. Sine inverse. And now I have the degree answer. So you should be able to do both. Okay, for fractional or decimal answers. So same thing. The next problem is a tangent problem. So this tangent problem should have both a degree and a radian possible answer. So let's do the tangent here. So tangent of negative 9.65. That gives us the degree answer. And we'll change our settings. Radians. Inverse tangent of negative 9.65. And you get the radian answer. All right, pause the video, try the student problem. Okay, student problem. Cosine of 1/3 inverse. So cosine of 1/3 inverse. That is our radian answer. And my degree answer. Cosine inverse of 1/3 should be about 70.5 degrees. And the tangent question, which is the second one for the student problem. So inverse tangent of negative 35.85. That gives us our degree answer. And that gives us our radian answer. Okay, so that's how to use the calculator. Alright, so I made you a chart for all of the intervals that we covered in Part 1. What's important is sine is limited to negative 1 out of 1, and its inverse is limited to negative half pi to half pi. And cosine is very similar, except that the inverse goes from 0 to pi. And tangent is good for all real numbers, but its inverse is only good from negative pi to pi over 2. And of course, it's all real numbers because tangent goes up and down forever. Okay, so when you have more than one thing happening in an equation when you solve, what you have to consider is the order of operations and the possible interval. So for each of the three examples here, there's an inside and an outside. Remember, the inside happens first, the outside happens second, because the innermost parenthesis rule for order of operations. So if I look here in the first problem, 0.6 for cosine is in the range for both of these. It's in there. Therefore, it'll work for cosine, it'll work for sine. So the result is 0.6. They'll just cancel each other out. Okay. However, the 3 pi over 2 is not in the range for inverse sine, right? is not in there. 3 pi over 2 is out here somewhere. So we have to go through and do the math first. So in order of operations, the innermost part happens first. So if I do that, I get sine inverse of something. So the question is, when is sine equal 3 pi over 2? Well, what is sine at 3 pi over 2? Well, that's 3 pi over 2. That coordinate is 0, 1. Cosine sine. And that value there is going to be a -1, because it's all the way down there. Okay? So then the question is, where does sine inverse equal -1? So what I have right now is this. Well, sine inverse has a limitation of pi over 2 to negative pi over 2. I can only be from here to here. And the only place that it equals -1 there is at this coordinate, which is 0, -1. So I had to have gone this way to get there. The question is, how much did you spin to get there? Well, you had to have spun the -½ pi to get there. So negative pi over 2 is the final answer for the angle. Okay. All right, in the next one, we have cosine and inverse cosine of 1.5, but the problem is 1.5 is not going to be between -1 and 1. Okay. So therefore, as a result, it's not going to work, so it's going to be undefined. And you can prove that to yourself with a calculator by typing it in. It's not going to give us a possible angle. Okay, pause the video, try the student problems. Okay, for the student problems, the 0.7 is in the range of cosine and inverse cosine, so we're fine. The answer is just 0.7. Okay, so here, if we do pi, sine of pi, we have to figure out where sine of pi is. So we do this. That's pi, and that coordinate is -1, 0. And the value of sine there is 0. So what we really have here is, when does sine inverse equal 0? Okay. Well, here's the thing. When you're doing sine inverse, sine is limited to these quadrants here, from pi over 2 to negative pi over 2. So then the question is, when is sine 0? Well, sine is 0 is here, isn't it? Cosine sine, which is going to be the 0 degrees. Okay, because we didn't have to move off the axes to get there. And lastly, the cosine inverse of -1.2. Well, again, -1.2 is not within the -1 to 1, so therefore that's going to be undefined. It's not possible, and you can try that for yourself by plugging it into the calculator. Okay, let's go to the last page. So all the combinations of trig function and inverse trig function to this point, whether both sine and sine inverse, or both cosine and cosine inverse, or tangent and tangent inverse. Now we're going to mix it up a little. But again, the order of operations still applies. So we have to do the tangent first. So if we make the triangle, tangent has to be between pi over 2 and negative pi over 2. Well, tangent is negative down here, so it could not be the fourth quadrant. Therefore, it has to be the first quadrant. And if I do tangent, that's opposite over adjacent. So the only thing I need to find now is the radius, or hypotenuse. So r squared equals 12 squared plus 5 squared, or r squared equals 144 plus 25, or r squared equals 169, or r equals the square root of 169, which is 13, okay, which is what I have here. So now that I have the triangle, I can do my cosine. That's the last piece to do here. Since I just did the tangent triangle, what's cosine? Cosine for this angle is adjacent over hypotenuse, so I get a 12 over 13. Pause the video, try the student problem. So now we have a tangent that is negative, but it's an inverse tangent, because you have to do innermost parentheses first in order of operations. Well, tangent is negative here, and tangent is negative here. However, I am tangent, so I have to be between pi over 2 and negative pi over 2. I couldn't possibly be these quadrants. Therefore, by default, since I can't be positive, I am down here. So this is my triangle. And tangent, I'm sorry, it has to be positive, not a negative answer. My problem's mixed up here. Since I'm a positive 3 over 4, I have to be in this quadrant up here. Okay, I'm not negative. I can't be over there. All right, so if I do tangent for my triangle here, that's opposite over adjacent. So my r squared equals 3 squared plus 4 squared, or r squared equals 9 plus 16. R squared is 25. R equals the square root of 25, so r is 5. Okay, so now we need to do the sine, which is the outer part, right? Order of operations. And sine is opposite over hypotenuse for an answer of 3/5. Okay, let's try the next example. Okay, so the next example, the innermost is sine inverse, and it has to be between pi over 2 and negative pi over 2, since it's a sine inverse. And if it's negative, that means it has to be in this quadrant, since this quadrant up here is clearly positive, and this is out of my domain. So if I do the sine, this makes a triangle, and the sine tells me this is 1 and this is 3. But one of those has to be negative. Radius can't be negative, therefore this has to be the negative one, which makes sense because it goes down. So therefore I'm missing the x. So 3 squared equals negative 1 squared plus x squared. So 9 equals 1 plus x squared. So 8 equals x squared when I subtract the 1. So the square root of 8 equals x squared, which is 2 times 2 times 2, which is 2 root 2 for the missing value of x. So that's 2 root 2, which is positive, which makes sense because it goes right and then down for the negative 1. Okay, so the next part is cotangent. Right, cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, so adjacent over opposite is cotangent. So that's 2 root 2 over negative 1, or simply negative root 2 over 2. Pause the video, try the student problem. Okay, next one, innermost first is sine. Sine is negative, and since it's an inverse, we're between negative pi over 2 and pi over 2. These are outside of our domain. We have to be in here. And since I'm negative, that means I have to be in this quadrant. And sine is going to give me a opposite and hypotenuse. And one of them has to be negative, so it has to be the 1, because I went down, and the radius can't be negative. So if I do 2 squared, which is the hypotenuse, negative 1 squared plus x squared, so 4 equals 1 plus x squared, or 3 equals x squared, or root 3 equals x, so root 3 is that. Typically it'd be plus or minus, but we know in this case it has to be a positive answer since it went to the right. Okay, cosine is what we need to do now, the outer part, and that is adjacent over hypotenuse, and that is root 3 over 2. And this makes sense because if you did the coordinate here, this coordinate, root 3 over 2, comma, negative 1/2, is my cosine sine answer. Okay? And you might also get some that are outside of the negative pi over 2, because you might get one that's perhaps, we'll do another example problem here, which do cosine, I don't know, we'll do a negative, I don't know, how about 2/3? And we'll do tangent on the outside. So if I did that case, right, cosine is from 0 to pi when it's the inverse, right? So I couldn't be these two. and I need a negative 2 over 3, so it couldn't be this one because that's a positive quadrant, and I have to be here for inverse cosine. Therefore my triangle has to be over here. So if I fill in my triangle now with cosine, cosine is adjacent over hypotenuse. Hypotenuse can't be negative, therefore it has to be that side, which makes sense. Left is negative. So now I just need my y value. So if I do that, 3 squared equals y squared plus negative 2 squared. So 9 equals y squared plus 4. So if I subtract 4, I get 5. So the square root of 5 equals y, which is really plus or minus. But since it's going up, it's going to be the positive 5, root 5. So therefore, when I do the tangent now, because tangent's on the outside, that's opposite over adjacent. So that's root 5 over negative 2, which makes sense, because tangent is in fact negative in the second quadrant. And that is the end of part 2.